And welcome to the June edition of Pulumi Office Hours. My name is David Flanagan. I am a developer advocate at Pulumi, and I am joined by my esteemed and wonderful colleague, Lee Briggs. Hey man, how's it going?
Good, thank you very much. Yes, we're excited to do. I think this is our second one now, right?
This is our second Office Hours. We started this in May, and then through some unfortunate events, we missed. Oh no, we were going to just start at June, and we were doing it at the end of June, so that's fine. We haven't missed anything.
Yes, we just sneaked it in to June, like by the skin of our teeth. So it still counts.
It does. It still gets awesome. All right. Do you want to just, for anyone that's not aware of both of us, we'll do a quick introduction. I'll let you, Lee, start. Do you want to say what you do at Pulumi and anything else you want to share?
Sure, yeah, I've been around Pulumi in all kinds of different roles, but currently right now I'm doing solutions engineering, which is primarily helping our customers be successful, and that involves showing the value of Pulumi early on in the process if they're deciding to become customers, or helping customers after they've adopted Pulumi in getting the things that they need to do with Pulumi done. So that might be helping them figure out which part of the cloud they want to use, or which part of the Pulumi language SDKs they want to use. So it means I get to talk about lots of different parts of the product, which is always exciting.
Awesome. Thank you very much for sharing. My role as a developer advocate is to help make videos like this happen and get good people to join us and talk about Pulumi. To focus on contributor experience and write blogs and just be trying my best to help make other people successful. Very similar to Lee. I think we're all doing awesome work. I'm very excited.
Absolutely.
All right, now the way this is going to work is I have scoured our Slack channel and found a few questions that I think would be interesting for Lee and I to just I can't even talk now to discuss today. We're going to answer them as we go, but we do want to try and encourage some audience participation. So if you're watching via LinkedIn, YouTube, or Twitter, please feel free to comment and reply, and let us know if you have any Pulumi questions. If you're watching this after the fact and not live, feel free to use YouTube comments or join our Slack community and ask questions in there. All the links are below in the description. All right, I'm going to pull up my pre-canned questions. I'm going to fire the first one at you, Lee, and we'll just start talking. So our first one came from David Wang in our Slack channel, and David asked, how do providers communicate like a cloud provider or AWS provider, and is there animate documentation? So David wants to know, when I run a Pulumi up command and we have all these providers, what is the communication model? What's happening? Do we speak to cloud providers directly, etc.? So, what's your thoughts on that?
Yeah, so I think there's different levels that we can talk to this in terms of like complexity, and I think the easiest answer to this question is that if you run the command Pulumi plugin ls, you will get a list of Pulumi plugins that are installed, and you'll see that they usually match up to a cloud provider that you are using, whether it be AWS or DigitalOcean or Google Cloud. That plugin is the actual process that talks to the cloud provider API. So it's generally a binary that lives in your on your local machine or wherever you're running Pulumi from, and that's the thing that actually reaches out and talks to the cloud provider API. Now we can go a little bit deeper here and talk a little bit about how that works and what actually what actually happens behind the scenes. And we have a really great page. I don't know if you have the link for this, able to share like the how Pulumi Works page. The how Pulumi Works page is like the canonical documentation here for how Pulumi is built and what it does. And there's three parts of Pulumi that I think are the most familiar for people to know. And essentially, they're all binaries that run locally on your machine wherever Pulumi lives. There's the Pulumi CLI, which contains the Pulumi engine. And the engine is a gRPC server that is listening on localhost. Something that we sometimes see from customers that have very high security requirements on user laptops is that it will say, hey, Pulumi's trying to connect to something and my firewall is telling me that I don't want to let them. And then we're like, it's on localhost. It's not going out to the internet anywhere. The CLI is talking to the Pulumi engine on your machine, and so allowing that gRPC dynamic port on localhost is a fix for that. And then there's the language host, and the language host is the thing that kind of interprets the Pulumi code that you've written and passes it to the engine to build this declarative graph to actually build the the end state of the actual infrastructure that you want to build. Once that declarative graph is built, that declarative graph gets passed over to the plugins that we actually talk to AWS. So there's three kind of bits here that are talking to each other, and they all come together to create this Pulumi experience. But the short answer for this question is that the Pulumi plugin is a thing that talks directly to the cloud provider, and it is all managed via these three different processes. Now, I used to work pretty closely with this. It may have changed slightly in the last few months, but that is my kind of like most recent understanding of how all these things work. And I'm sure if one of the engineers is listening and I've got that horribly wrong, they will reach out to me and say, actually, no, that's not the way it works now. But at a very, very high level, those are the things that you need. And I think this comes in really useful if you are doing something like packaging Pulumi in a Docker container yourself. You can't just have the Pulumi CLI. You also need the language host, which is usually of the format Pulumi language something. So we've got Pulumi language Java, Pulumi language Go, Pulumi language Node. And then you also need the plugin. The only caveat to the language host is that with the YAML support, you don't actually need a language host. Oh wait, no, we do have a language host for YAML. So I'm talking nonsense. So all of the languages do have a language host that talks directly to the Pulumi engine, and that's like the high level idea of how it works.
Very cool. That was a lot of information, but very, very useful. So thank you for sharing that. So, David, we hope that
I always like to give like the short version, which is like actually answers the question, which is the provider binary is the thing that talks to the cloud provider, and then like the actual context of how it all fits together is usually useful for me at least. So hopefully, this page here is a really great read if you are starting out with Pulumi and starting to understand how it all works. So I would highly recommend reading it. It's not super super in depth. It's just a kind of high level idea of all the different pieces.
Yeah, I mean, I love the architecture of Pulumi, and I love the fact that everything speaks over gRPC and everything is kind of its own thing. It can evolve independently. They can make changes. Because it's gRPC, you can write plugins and providers in pretty much any language you want, as long as it speaks gRPC, which is very cool. So lots of awesome stuff there.
Yeah.
All right, let's move on to question 2 from my favorite username of today's show, Pulumi Novice. Pulumi Novice asked, how capable is Pulumi for Kubernetes configuration, or is there another GitOps tool for this? So to kind of,
well, I think I'll start with this, and then I'm going to pass over to you, David, because I think actually you are very familiar with this space. I've talked about this on Twitter before, and so I'm going to take the opportunity to talk a little bit about it. On a live stream. I think there's two parts of your infrastructure as code experience, and you can compare other infrastructure as code tools and look at the different features, but the experience that the user gets is really important. And the two parts of any infrastructure as code experience is the authoring experience, how it feels to write the infrastructure programs, and what experience the users get when they're writing their infrastructure programs, and then the execution experience, like how you actually get that infrastructure program from wherever you've written it and stored, whether it's on your local machine or in a Git repo or wherever that is living, and then how do you get that onto the actual infrastructure itself? One thing I always like to talk about, if you're in the Kubernetes space, you are probably pretty happy with the Kubernetes reconciliation experience, like the constant reconciliation loop. And lots of people are using tools like Argo CD and Flux, and maybe they're even defining their infrastructure with a reconciliator that is going to talk to an external cloud provider, for example. But the authoring experience is always different for those things. And it's the same, because it's always usually YAML focused or configuration file focused. What I think is unique about Pulumi's Kubernetes experience is that that you can have a different authoring experience that feels more familiar to people who might not be working with Kubernetes on a day-to-day basis. And so like to answer the question of like, what is the experience with, Pulumi and Kubernetes around GitOps? For me, the authoring experience when it comes to that stuff is really, really important. Like being able to define abstractions in Node or Python or Go that allows me to write a packaged up Kubernetes resource like a deployment service and ingress. That's really where like Pulumi shines in being able to have a great authoring experience. Now I'm going to pass to you for execution experience, David, because I know that you're really familiar with this kind of realm, and I know you've used a lot of different things here. So in your experience, like once you've written your Pulumi program and you've got it written down and you are ready to actually apply it to a cluster, like what are some of the options from an execution experience that you can do with Pulumi?
Yeah, well, you've already mentioned two of them, so we'll start there. You mentioned Argo CD and Flux. So if you want to use those tools as your GitOps tool of choice, your controller to do the reconciliation, then you totally can. There's two ways to do that. You can use custom plugins with both of them, which allow you to execute arbitrary commands, such as Pulumi up. And that will work. You're not going to have a great experience, though, because the thing with Kubernetes is pods disappear pretty quickly. And what you don't want is for your Pulumi up to be halfway through and a pod to disappear, and Pulumi has to kind of recover that state. So you can use two more options. First one is we accept a render to YAML option on the Kubernetes provider. So a Pulumi up will not modify the cluster. It will instead generate all the YAML config files, allowing Argo and Flux to apply them in a standard fashion. And that's a pretty nice way of doing it. However, we also have the Pulumi Kubernetes operator. So this is built with steps for remediation if the pods should disappear, and it will handle doing a native Pulumi up without the render to YAML, working with the cluster in a much nicer fashion. It's what I use every single day on all my clusters. It's a fantastic tool. And like Lee says, like when you've got that rich authoring experience with types and autocomplete in your IDE and code, just moving that Pulumi into another Pulumi process inside a cluster and doing GitOps that way works really, really well. So end to end, I'm pretty happy there. So.
Yeah, and I think we see this a lot in the community, and actually something that I talk about, or I've wondered about, that maybe you have some insight, David, is like it's been a couple of years since I've used Argo CD in Anger and certainly a production level environment, but I seem to remember that once you actually have defined the app or the app of apps in Argo CD is great at doing that reconciliation. Like it'll pull the manifest from some upstream Git repo and continuously apply them, and you have a bunch of different mechanisms for like rollbacks and all that kind of stuff. But defining the apps was always something that I found interesting in that kind of mechanism, because I did it with JSONet, right? Like back before Pulumi was actually, in my life, so to speak. I wrote a bunch of JSONet abstractions to actually define those Argo CD apps, because it kind of seemed strange to me that you would have to go into this web application and create all of these, these applications you wanted to apply. So, I'm always curious when people say, well, we're not going to use Pulumi because we've gone down the Argo CD path. And I always wonder, well, how are you getting the applications onto Argo CD? How are you defining them? Because surely there has to be something there that is like the bootstrapping mechanism and all that kind of stuff. And in your experience, how are people actually, going and defining these Argo applications and even the app of apps model?
Yeah, exactly. I love that you mentioned JSON because I also went down that rabbit hole many years ago, and I think it's a classic example of there are tools out there to help provide abstractions and remove the verbosity of producing Kubernetes YAML and the kind of tedious nature that it can be. But the learning curve of these tools, particularly JSON, I don't know about you, but I struggled for a while before I finally started to kind of make heads and tails of it. So I think that's just another.
I don't think I ever really. I don't think I ever really did. I did a lot of googling and a lot of like, well, this works, and I have the output, and I'm not really sure how I ended up with this, but it works, so I'll leave it at that.
Copy paste, run the compiler.
Yeah, absolutely. Yeah, I mean, like defining just a simple JSON string was always easy, and then once you started to go down the abstraction route, it was really, really complex. So yeah, I agree with that.
Yeah. So Pulumi lets you use the tools you're already familiar with. So I don't think that is something that should be understated. Like it's such a superpower. So yeah, we're really happy with Pulumi and Kubernetes. So thank you for your question, Pulumi novice. Uh, we'll I'm sure we'll do plenty more Kubernetes stuff in future. So
Yes.
all right, let's take a look. We've got Trevor Ackerman who has a question. Can anyone recommend a simple solution to generating a self-signed certificate and adding it to the private key of a fargate ECS instance? Now, I picked this question because you actually answered this for Trevor. So I figured we could talk about that and share a link with our audience. So,
Absolutely. So Pulumi has a TLS provider which allows you to generate all manner of certificates, including signed certificates from an existing certificate authority if you really want. In this particular case, we want a self-signed certificate. So I actually ran into this a long time ago. Somebody else asked a similar question about defining a bunch of certificates for a self-sign mechanism. And this is really common if you're doing something, again, actually in Kubernetes, if you're doing something in Kubernetes, you generally might want a self-sign certificate inside the cluster for like TLS communication between two services. And so
yeah.
defining self-signed certificates is something that you might run into at some stage. And so the TLS provider makes this relatively straightforward. There's a few like as with anything TLS and SSL based, there is a few hoops to jump through, and you have to have a reasonable, intricate knowledge of how it all works. But with the TLS provider, you can take all of those steps. And I think if you look in the TypeScript folder in this is my Pulumi examples repo. If you take a look in the TypeScript folder there, and then there is at the bottom, I think it's like a self-signed certificate example, which hopefully still works. I maintain no contract of that any of these examples work. They're designed to be reference points rather than actual production examples. But here you can see I'm just using the TLS provider, creating a private key with a self-signed cert that is going to pass that private key. And so we're going to create the certificate authority first, so that we can actually sign any certificate with a certificate authority. And then you can use that certificate authority, all with the TLS provider, to create a certificate signed by that. And obviously you would have to, if you're going to use this for your local host or something like that, you would have to trust that certificate in some way, and so you'd have to export that certificate CA cert. But this creates a self-signed certificate, and you could package this up into an abstraction, right? So you could package this up into a Pulumi component resource or even a multi-language component resource that would handle a lot of this stuff for you. You can see here the things that I'm exporting are the things that I'm likely to use when I'm using this self-signed key. So like the certificate PEM itself, the private key for that certificate, and then obviously the CA cert so that I can actually trust it. And this is a pretty canonical example of how to do this. One thing that I would think I never really talked about for the fargate side of that question was, once you created this self-signed certificate with fargate specifically, you need to decide really where you're going to put that certificate. You need to either embed it into the Docker container with the application, because with fargate you don't actually have access to the host itself to manage the certificate store. Or you would put it on a load balancer like an ELB or an A. I think only Fargate only supports an ALB. So you would have to install that certificate and the private key and the CA certificate inside the load balancer as well. So that is the full kind of like end-to-end answer to that particular problem. But I'm really glad you brought up my examples repo, my little playground.
Yeah, well, we're going to take a look at a couple more examples, but before we do, I want to follow up on one thing that you said there, because it's actually quite pertinent. Is you mentioned Kubernetes, and ironically, I don't know, no, coincidentally, I'm not sure, pick a word, but I have a blog post which is coming out tomorrow, which is actually deploying an admission controller with Pulumi to a Kubernetes cluster. And there's this really annoying gotcha with deploying admission controllers, and that they need a self-signed certificate, but not only that, you can't generate it in the cluster because you have to attach the CA bundle to the admission request custom resource thing. And doing exactly like Lee has done in this code here, Using Pulumi, it allows you to generate certificates, bundle up that key, and attach it to your Kubernetes resource all within your environment. It's pretty sweet.
The more we talk about this, the more I'm starting to wonder if we should create a multi-language package that is just basically self-signed cert with the inputs being the sans and like the list of sans is the only input there, and it does all of this for you and exports it. I think that would be a pretty useful multi-language package actually, so you don't have to
Yeah.
kind of go through this process every single time. And just if you're not familiar with Pulumi's multi-language packages, it's just a mechanism or an abstraction that allows you to write a reusable abstraction in one language and make them consumable by all of Pulumi's supported languages. And so a self-signed certificate would be really useful there. And so I might go and have a crack at that on my Friday evening and see if I can get that pulled off.
Awesome. All right, so let's talk about your examples repository. So Jack Storm on GitHub, JAXX Storm
Yes.
/ Pulumi dash examples. Now there's quite a lot in here, but is there anything
Never pick your GitHub nick. Never pick your GitHub nickname when you're 13 years old. Is all I will tell you. Yeah, that made sense when I was 13. So yeah, there's a lot in here. So the reason that I started this, we have the Pulumi examples repository, which is at Pulumi/examples in GitHub, and that has some really great like end-to-end examples of how you might deploy an API gateway, as you can see there, or deploy a Kubernetes service or something along those lines. And I wanted a place to put less canonical examples of how to do something in a way that kind of like as a reference point for me. Like when I'm solving problems for customers, I almost always come up have to solve that problem again later. And so I just created this examples repository to start down that path. And then I had the wild hair to abuse Pulumi's YAML support, and it got a bit out of hand with the Lua and the Pascal and the Fortran and the Lisp and I think one of my incredibly talented colleagues added a brain F example, as you can see at the top there, which if you click on that, it will really kind of give you an interesting experience of what it's like to. That's a valid Pulumi program to deploy an EKS cluster in Kubernetes, and it works, by the way. And I would highly recommend trying it because it just is crazy, but it does work. And Pat, one of my extremely talented colleague, definitely tried that out, and it works. But there's lots of different examples in here of if you go into the Python example here, I think there's some really interesting examples here that maybe aren't kind of ready for prime time in the Pulumi examples repo. So if you're my favorite example here, if you go into the AWS folder, then there is a wait for load balancer at the bottom here. And I think this is a really interesting example of being able to actually use so this uses the AWS Boto SDK inside an apply. And what it does is it uses the Boto client to actually pull a load balancer that I'm creating with Pulumi and uses the waiter mechanisms in the Boto SDK. So on line 19, you can see waiter equals client.getWaiter load balancer available. And because Pulumi is asynchronous and you have that apply mechanism, you can actually poll things inside the apply and actually use the waiter to verify that the load balancer is healthy and active. And so this is a really, really powerful example of what you can do with Pulumi that you can't always do with other infrastructure as code tools. Or if you can do it, it's going to involve a lot of kind of complexity. And this is just off the shelf kind of available support in Pulumi. So this is one of my favorite examples that I like to use. This is of course supported in all of the different languages. You would just need to install the SDK for TypeScript or Go or whatever. And those waiters are now available in all of the different languages as well. So this is something that This is actually something that I was using yesterday for an example for AWS. If you have used AWS IAM, you'll know that it's eventually consistent. And so if you want to do any kind of complexity with assume role in your Pulumi program, you have to wait for the IAM role to actually exist and be active. And you could just use a waiter inside and apply, and it just blocks all of the other resources, and it allows you to do some really pretty special things here.
Yeah, I had no idea you were going to pick this example, but I love it because it's one of those questions that I think you probably get all the time, I get all the time, and people are like, well, how do I wait for this, or how do I check this, or how do I do this? Pulumi doesn't have a function for that. And my answer is always, well, use the SDK. Like, go to the AWS SDK, use the GCP SDK, use the DigitalOcean SDK, because it's just code. Just pull in the library and then write the code or the logic that you need, and it'll just work. And this is a wonderful example of doing that. So very, very cool.
I just wish I'd done more. So what I've done with this actual example is just write to a file, and I thought, well, I mean, if it was a little bit more of a complex example, you could like wait for the load balance to be active and then set a health check to start or something along those lines. I've just written this, the ARN to a file and set the apply. But hopefully this is like the whole point of this examples repo is to give you an idea of what is possible rather than the actual answer. So hopefully that gives you an idea of the things that you can do with Pulumi. And the apply logic is honestly one of the most the most common things that people ask me about in terms of how to understand it. But once you get your head around it, it really does. It's really, really powerful.
Well, guess what the next question is about? It's about apply.
I'm guessing it's about an apply. Yeah, absolutely. Was surprise. Okay, excellent.
All right. Well, before I move on to that next question, we did get a comment from Harium who said amazing. I don't know if that was in regards to your waiter or to the brainfuck example, but we'll just assume both. So,
yeah, why not both? Yeah, why not both? Yeah.
Okay, so our next question came from Anurag Naluri. And the question is, can I rely on using sa.email? So this is an output on a service account after calling service account.new account. Or does that run asynchronously and populate with promise-like values? So yeah, we're leading directly into how the apply system works inside of Pulumi. So do you want to explain what happens when you reference an output on another resource?
I think the best place to start here is just to talk a little bit about what an output is. If you are familiar with other infrastructure as code tools, this might make sense to you explaining this way. But when you create something in a cloud provider, they all value your time in slightly different ways. So, for example, if you create an EKS cluster, it's going to take between 5 and 10 minutes to create that cluster. And when you create in that cluster, the properties that exist on that cluster come up in different orders and arrive in different orders and have populated at different times when you're creating that resource. And so you run a Pulumi up and you create an EKS cluster, and the Pulumi resource provider, which we talked a little bit, the Pulumi plugin, which we talked a little bit about earlier, will continuously poll the AWS API, waiting for that EKS cluster to populate. Some of those output values, like for example, the ARN of that particular EKS cluster, isn't populated until the full process is completed. Like the cluster is up and running and all of those values now exist. We call those outputs. And you can pass those outputs to other Pulumi resources as inputs. And that's how Pulumi builds its graph. You create an EKS cluster and then you pass that EKS cluster API address to the nodes that are going to attach to it, for example. And in order for that to work, you need to wait for that cluster, so that API address to appear and actually exist. And so in this particular example with the SA email, like that is I think it's an input and an output, because usually an input is also an output. And so we actually have to wait for that value to exist in the Google Cloud API before we can actually use it. And so you could pass that to another Pulumi resource with no problem, and Pulumi builds that dependency graph for you. So if you say create an sa.email or whatever, and then pass it to another resource, Pulumi goes, okay, well, I need to wait for this value to appear, and then I can start creating this other resource, or that can be an input. Where this really gets tricky is if you are passing that value to something that doesn't support an input. That's where the complexity comes in. And what I mean by that is sometimes you will need to pass those output values to something that only takes a string value in the upstream cloud provider API. So the very common example of this is with IAM policies. They only support string values. They don't support input values. And what I mean by that is that you actually have to have all of the known values up front before you can populate it. And an SA email is a great example of that. Like an IAM policy in Google Cloud only takes a string. And so what you have to do there is you have to wait for the cloud provider to say that this value has been populated and is allowed, and then do something, and then actually perform an operation. And building a string is a great example of that. And the most common question we have in the Pulumi community is, how do I convert an output string to a string? The answer is you can't. It's not possible. Like, you cannot convert an output string to a string. All you can do is resolve that value and then use it once it's resolved. And that is essentially what apply is doing. You are waiting for the value to turn up, and then inside a function, you are able to use that value. So to come all the way back to the question, because I went around the houses a little bit here, the short answer is that it's an async value. It is eventually populated. But once you realize that it's eventually populated, then there's things that you will have to do depending on how you want to use it. So if you want to pass that value to another Pulumi input, that's totally fine, and Pulumi handles that for you. If you want to use that in, say, an IAM policy, you will need to use an apply. And I wrote a blog post around this about a year ago on my personal blog. And I usually keep things like this on my personal blog because it's not always the most professional writing. And so I like to, throw a few curse words in there and all that kind of stuff. So, and mainly I like to mock myself a little bit in these things. And so this is the blog post that I wrote, I think it's about a year ago now. Oh yeah, over a year ago. That kind of just explains my understanding of this. And the reason I wrote this is because I think I've only just fully understood how Pulumi Apply worked at this point, and I'd been at the company for a year and a half. So, it was my kind of my mechanism to actually kind of know that I'd learned something about how this worked. I still think this is the best ever subtitle in a blog post that I've ever written.
I'm just laughing at the H2s all the way down. We could eventually
I know.
What the hell? Back to inputs.
I don't think I can get away with putting this on the Pulumi blog. And Apply Me a River, I just think is excellent punnage, by the way. I'm really proud of that one.
Yeah, and a great example of using the apply to get a real string value for populated user data, cloud init config, etc. So, yeah, very, very cool. Your blog is available at leebriggs.co.uk.
leebriggs.co.uk. Yes.
Awesome. Again, I will put all of these links into the description as soon as we finish. So don't worry about writing that down. They'll be available soon. All right. Any last comments on apply? Or are you ready for the last question of today's session?
I think I'm ready for the last question.
All right. Sweet. So we got a question from, in fact, you know what? I said Pulumi Novice was my favorite name of the episode, but I may be wrong. This name is Dag.
It's been superseded by a better name.
Yeah, we got Dag. So Dag says, is there any way of performing the equivalent of a kube control annotate namespace default foo equals bar without using local command and kube control? So let me give some context about this question to anyone who's not familiar or doesn't understand what's been asked here. What Dag is saying is that on the command line, I can run kube control annotate namespace default foo equals bar to augment an existing resource with some new metadata. And they want to know if they can do that in Pulumi, but without using our local command provider. So local.command, kube control, etc. And the answer is, Lee,
soon you can, yes.
I was hoping you would say soon.
Yes, soon. Yes, soon. I think there's a little bit more context here as well that I think is always useful for. And again, I'm coming back to EKS. I've said a lot about EKS today, but I think
Yeah.
this applies to AKS as well. When you create a managed service Kubernetes cluster, like I know you, David, have generally created clusters from scratch a lot of the time, use a cluster API or something along those lines. And what's nice about those cluster API clusters is that you can basically have full control over how they work. If you create an EKS cluster, you get a bunch of, like, EKS provides you with a bunch of resources by default. So, for example, the VPC CNI daemon set exists on the EKS cluster by default. And then AWS has this AWS auth config map, which like maps IAM roles to service accounts and permissions in Kubernetes. And those things turn up inside the cluster, but you cannot manage them with Pulumi without importing them as it currently stands. You would have to do a Pulumi import operation in order to actually do anything to them. And it's always kind of confusing to anybody coming from the Kubernetes land, because you can use kube, and I call it kubectl rather than kubectl. So kubectl apply or kubectl patch, or just manipulate the existing resource and only change the fields on the cluster because of the server-side apply mechanism, and that's always really, really powerful. And so what we're doing, and what Levi, my incredibly talented and esteemed colleague Levi, who does a lot of the work on our Kubernetes provider, is currently working on, is the server-side apply mechanism in the Pulumi in the Pulumi Kubernetes provider. So we had a really great conversation. I know you were involved in this, David, about all the different ways we could potentially support server-side apply, because it's not as simple as just turning on a flag. And I think what we decided on is we're going to add new resources for each of the supported Kubernetes resources in the provider, but with a patch verb at the end of them. And so you'll have a deployment patch and a service patch and a config map patch, which again will allow you to essentially have full control over the way that server-side apply works inside Kubernetes. I like to keep up with most of the infrastructure as code tools. I won't name them, but I'm sure you all know what they are. And I don't believe that they support this at the moment for all resources like we're planning to once this ships. And so once this is enabled and turned on and we release a version of the Kubernetes provider, every single field on the Kubernetes API will be patchable, which I think is really, really powerful and is going to solve a lot of pain around some of these managed resources and all that kind of stuff. And it comes back to the annotate thing that you already talked about. The default namespace is a great example. It exists in every Kubernetes cluster. If you want to manage the default namespace, you have to import it at the moment. And when we turn on server-side apply, you'll just be able to do a patch namespace and everything will work great.
Yeah. I mean, you've covered so much there, but I'll add a couple of things. Is that, so far in Pulumi Kubernetes, like you can enable dry run on the provider configuration, which does a server-side diff. That was our first foray into kind of supporting server-side apply. And that's pretty cool because it means that we are always taking a look at what's in the cluster and trying to reconcile that appropriately. I think server-side apply has already been merged. In fact, I'm pretty confident that's already been done. But one of the challenges when we were discussing how to implement this is that for the patch, if we were to use the original resource, we would have to actually escape the type system. Because Kubernetes has this really weird thing with server-side apply, and that you can deploy or apply a deployment manifest that only has one field, and that's replicas. No containers, no images, no nothing, right? And it does that because it has a concept called managed fields, which means that then that controller or that kube control command becomes the manager of one particular field on the resource. And to support that in Pulumi, we don't want to allow people to use deployment and then not specify anything, because for people that aren't trying to do a patch, would lose that type safety of their deployment. So we've went down the route of adding a patch to all resources. I'm super excited about this for all of the reasons that Lee has already covered. I think it's going to open up just a whole new world of things that we can do with managed Kubernetes clusters and even bare metal ones. Like it's really cool the way that we can do managed fields on particular aspects and still consume other tools inside the cluster to do what they want to do, like maybe cert manager. So there's lots of really cool things we can do with this new feature. Very cool.
Yeah, I think the thing that I think is the other thing that comes up, and maybe you know more about this, but we often see that with the Kubernetes provider, there's this last apply configuration field that exists when you're doing client side apply, and we've had an open issue here, in that this is one of the very few places that we consider ourselves to be quote unquote leaking secrets. We're not actually leaking secrets because the secret is still encrypted in state and is encrypted in encrypted in the Pulumi CLI and in the engine. But when you do a Pulumi up against a Kubernetes cluster, because of the way that the last applied configuration field works, if you have a secret value in your deployment, like an environment variable you've secreted inside Pulumi, it turns up in plain text. And that is very frustrating to users because as soon as they talk to the Kubernetes API, it goes into plain text. And my understanding is that last apply configuration field no longer required for server-side apply, which means that you don't have that value there. But I could be wrong about that. So happy to be corrected there.
No, you're right. With server-side apply, we no longer need the last applied configuration. But I'll also point out that the secret being exposed in the last applied annotation is only if you're using Pulumi secrets and then putting them directly onto the manifest and not storing them in a secret and consuming them through environments. So you're already kind of went down a bad path.
Which is the correct way, yes.
Yeah, so if you adhere to best practices, Pulumi will never leak your secrets in your Kubernetes cluster. But sometimes we skip corners because we need to fix something. P1s are a real thing. So I don't know. I'm not judging you. Do what you need to do. But last applied configuration will disappear, and server-side apply and manage fields will be the default very soon. So very, very cool.
It was also very strange to see this massive JSON blob inside a YAML object for me personally. Like, you would see this huge JSON object in last apply configuration. We're like, is that the whole resource? And it is. So yes, that is always that is nice to not have that there as well, like a small quality of life improvement, especially compared to some of the other stuff we talked about. But
Yep.
I get joy out of those small quality of life improvements for sure.
Me too. Love them. All right. Well, we are approaching time. Lee, you've been wonderful. I just love being able to kind of sit here for 40 minutes, 45 minutes, and just get that knowledge out of your head and share that with people because you are super smart. And I really appreciate you joining us today.
You're gonna make me blush if you're not careful, but I appreciate you too, and thanks so much for putting this together. It's always great to just have a chat about technology, and hopefully we'll be able to do it in person again soon.
I hope so. All right, to people watching, the links will be in the description soon. Feel free to leave comments and questions in Slack or on YouTube. Again, all links in the description. And Lee and I will be back next month. So until then, we'll see you all soon. Have a great day.